Okay, so this is notes 1-1. So in Canvas, it'll say Unit 10. We just kind of, instead of starting back over at 1, we just said call it 10. But on the notes and on the assignment, it will be labeled as 1-1. Okay, so we're going to be graphing inverses. So if we happen to be at home and doing this virtually, if you don't have a calculator at home, I'm going to show you how to use Desmos, which hopefully you have on your iPad. So just keep in mind, if you do have your own calculator at home, that you will be able to use that, and you know how to plug in an equation in y equals and find the points from the table. So we've done that plenty of times. So you're welcome to use that or use Desmos. I don't really care. Okay, so it says create a table of values in table 1 for the equation given. So we're going to plug in y equals 2 to the x. Again, you can use your calculator at home if you have it, or you can use the Desmos app. So I'm going to show you, if you go to the Desmos app, so it should be green, you can type in the equation, but you have to put y and then equals, so you're putting exactly what you see. 2, and then the exponent, if you're raising it to an exponent, use that a to the b power, and you can use whatever exponent you want. So in this case, an x. So that's our example that we have on our notes. So we're trying to find the table of values from that. So you can go to this little bar up at the top and use the table, and then you can see the table of values. So let me go back and do that again. So y equals 2, and then the a to the b, and then x. So if I'm going too fast, just pause it, and then you can watch it again. And then I'm doing that little, right to the left of those 2 arrows up at the top, I'm using that button there. And then you can select the table. Okay, so I'm going to write those points down and fill in my table on my notes here. So for table 1, I'm putting in the points that we just found: -2, 0.25, -1.5, 0, 1, 1, 2, and 2, 4. We're just going to stop there, okay? Or you can be using your calculator. So it tells us to create the table from table 1, or create the values, and then we're plotting the points. So I'm going to go over here and plot it on this graph. So -2, and then 0.25 would be somewhere in this area. -1.5, 0, 1, 1, 2, and 2, 4. Okay, so remember we've talked about, notice this is an exponential graph because x is part of the exponent. So remember we've talked about that with that exponential growth and decay. So remember it's not ever crossing that x-axis there, so make sure you don't go below it. Okay, so if we look back up at the top, it says after we plot the points from table 1 on the graph, we're going to switch our x and y coordinates and record it in table 2. So I'm going to use a different color for that. So I'm just switching them. I'm flipping them. I'm not changing the value. I'm just flipping them. So instead of -2, 0.25, it's going to be 0.25, -2. So I'm just flipping those points there. And then 0.5, -1, 1, 0, 2, 1, and 4, 2. Okay, so now it says go ahead and plot those points. So 0.25, -2, be somewhere in that area. 0.5, -1, 1, 0, 2, 1, and then 4, 2. So notice this one looks a little different, and as I'm connecting my points, notice it's getting closer to the y-axis instead of the x-axis. So make sure you're not crossing that y-axis there. Okay, so going back up to the top, after we plot our points from table 2, we're going to draw the line y equals x. This line is going to be very important. We're going to be using it a lot this section. So y equals x, if you actually graph that, If you don't know what it equals, so I can type in y equals x. If I want to look at the table, I can, but notice it's a straight line that crosses at the origin. You can look at your table. It's -2, -2, -1, -1. Notice the x's are the same as the y's. So whenever we sketch it on our paper, it says draw it as a dashed line or a dotted line. So I know I have a point at 0, 0, and then 1, 1, 2, 2, 3, 3. So I'm not actually plotting the point. I'm just drawing that dashed or dotted line there. So it keeps going the opposite way too. So basically every little corner there, you should have a little point. So this is the line y equals x. So that's what we're going to be using a lot this section. So it says look for some patterns. So we can look at that one right now, but really I think we need to probably do another example before we can actually see what's going on. So again, you can use Desmos or you can use your calculator at home if you have one. Just plug it into y equals second graph and you can look at the table of values. All right, so let's look at number 2. Notice this equation is linear. How I know that? It just has an x there. So it should be a straight line when I graph it. Again, you can use your calculator or you can go to Desmos. So I'm going to type in, if I'm using Desmos, y equals, I have to type in the whole thing. Negative, you're just going to use the minus sign. So -3, your x, and then +1. So again, if I'm going too fast and you're not able to follow along, just pause the video and then go back and hopefully you can find it. If you have any questions, just make sure you communicate, email, or whatever you need to do. Okay, so I'm going to go back to that little bar up at the top, and then you can click on the table of values. So there are tables or our x's and y's for y equals -3x + 1. We're going to copy that down on our notes. So our first one's -2, 7, -1, 4, 0, 1, 1, -2, and we'll stop there at 2, -5. So we're going to go ahead and plot those points. So -2, 7, -1, 4, 0, 1, 1, -2, and 2, -5. All right, so make sure that when you plot your points, go ahead and connect them. Make sure you extend it throughout your graph. Don't stop. And then if you look back up at the top of the notes, it tells us to just switch our x and y coordinates and put them in table 2. So I'm going to have 7, -2. 4, -1, 1, 0, -2, 1, -5, 2. So I'm going to plot those points. 7, -2, should be right there. 4, -1, 1, 0, -2, 1, -5, 2, and then again make sure that you connect them. Let me go back. Connect them and extend it throughout your graph. So after we plot those points, make sure that you are drawing your y equals x line. Remember, that's not ever gonna change. It's the equation y equals x. So 0, 0, 1, 1. Just make it as a dotted line. So there's our y equals x line. Okay, so it told us at the top that we wanted to look for patterns. So if you look at both of the lines that you drew, and then if you also compare it with that y equals x line that you drew, you should notice that on both sides of that y equals x line, it's like a reflection. So here's, if you look at this one, there's that point. Notice it's across that line here, 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 here. So notice it's just reflected. Same thing here. This point is reflected there, 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 and so on. So it's a reflection over that line y equals x. So if you remember what we did to get from table 1 to table 2, all we did was we switched our x and y value. So it says, what do you observe? So when we switch the x and y coordinate, then the graph is reflected over the line y equals x. Okay, so anytime we switch x and y, we graph both of them, the original and then whatever we switch, that is going to be a reflection over the line y equals x. Again, any part of this video, if I'm going too fast, just pause it, do what you need to do to fill in your notes, and then always contact us if you have any questions. So let's go ahead and flip over to the back of the notes. Notice it says when two graphs are reflections of each other over the line y equals x. So that's exactly what we had on the front. Then they are said to be inverses of each other. So that's our main focus today, is finding inverses of each other. So inverses, all you're doing to find those is you're switching your x and y coordinates, and then that's the reflection on the graph over that line y equals x. So on number 3, it says find the inverse of this relation. Remember, we've gone over relation before. That's just a set of ordered pairs. So we have out a list of ordered pairs here. We're just finding the inverse. We just said inverse, all you have to do is switch your x and y value like we did on the front. So if I list out the inverse of this, all I'm doing is I'm switching those x's and y's. So negative 3, 4 would be our inverse point. Negative 1, 2, 0, 7, 4, negative 1, and 10, 2. So it's really easy here. You're given just a list of ordered pairs, which is a relation. Just switch your x and y's. That's your inverse graph, or inverse relation. Okay, let's look at the next section. It says graph each of the following functions. Read the instructions carefully. We're going to graph the line y equals x. We're going to reflect those points to find the inverse, and then we're going to determine if the inverse is a function. So function, remember we've gone over before, a function is where all of your x's are different, so none of your x values repeat. So if you remember on a graph, to determine if it's a function, we use the vertical line test to make sure that all of those x's were different. So if you notice on number 4, this is again linear because we have an x and a y here. So notice this is in standard form and not slope-intercept form like we had on the front. So before I can plug it in, I need to go ahead and get it in slope-intercept form, which is y equals mx plus b. So I'm going to get y by itself. I'm going to subtract 2x. We've done this before. This should be a review. We have a negative y equals negative 2x, and then bringing down that plus 5. We're not finished because we don't have y equals. We have negative y, so divide every term by negative 1. That leaves you with positive y equals positive 2x minus 5. Okay, so now I'm going to go, again, you can use your calculator if you have one at home, or you're going to the Desmos app. So go ahead and go to that, and we're going to type that in. So y equals 2x minus 5. Again, go up to the top where you see those 2 left double arrows to the left of that. You select it and then choose the table. So I'm going to write down those table of values on my paper. So So that would be -2, -9, -1, -7, 0, -5, 1, -3, and 2, -1. Okay, so after we find those, we're going to go ahead and graph it. We could also, since this is in slope-intercept form, we could also use our slope and y-intercept to graph it. So if you didn't want to use a calculator, you can still get that graph. So -2, -9, -9, -1, -7, 0, -5, 1, -3, 2, -1. Remember I said on the other ones, make sure that connect your points, but make sure to extend it throughout your graph. Okay, so we graphed the relation, which is the original here, and then we're going to graph the line y equals x. So remember, make sure that's a dotted or a dashed line. Okay, and then we're going to reflect the points. So we did on the front, we reflected the points on the front. So all we have to do is just switch these x and y coordinates. So -9, -2, -7, -1, -5, 0, -3, 1, -1, 2. And we're going to plot those points. And then we connect them, make sure you extend it throughout your graph. Okay, so looking back at our instructions, it said determine if the inverse is a function. So make sure that you are labeling your inverse graph so you know which one's which. The second one was the inverse because we switched those x and y coordinates. So I'm just going to label it as inverse. We're looking at that. If we use the vertical line test across the graph, notice there's no repeating x values. So yes, the inverse is a function. Anytime you have a linear, straight line, it will always be a function. All of your x's are different on a linear function. So having to do a couple of things here. You can use the Desmos app or you can use your calculator at home if you have one. All right, now we're going to take a look at number 5. Notice y equals x squared is a quadratic equation. We've graphed these before. Remember, they're parabolas, so they open up or sometimes they open down. So if you don't remember what y equals x squared looks like, that's the parent function. You can go to your calculator or Desmos app. We're going to type it in. Y equals x squared. There's our parabola. Go up to the top to select the table. And then we can write those down on our notes. So -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. So I'm going to go ahead and plot those points. I'm going to connect them. And then make sure you extend it throughout. We could keep plotting points, so make sure you put arrows at both ends there. After we graph the original, remember we are to graph the line y equals x as a dotted line. So remember on the front I said we would be using that a lot. And then we're going to graph our inverse. So remember we just switch our x and y to find our inverse for -2, 1, -1, 0, 0. Notice that one doesn't change. Neither does the 1, 1. And then for 2. So let's plot those points. Okay, make sure you connect them. We could always keep adding, so make sure you also put arrows at both ends. So we are looking to determine if the inverse, so make sure you label that one. You can use different colors if you want. So the inverse was that second one, which was the blue one. So we're using the vertical line test. Use your pencil to go across it, or draw lines if you want, but notice it's crossing at two different places, which means those x values repeat, so this would not be a function because those x values repeat. Remember, we're looking at the inverse to determine if that is a function. So again, you have to know which one's the inverse on your graph. Okay, so let's take a look at the back. So notice this one is also quadratic because it has an x squared. We know it's going to be a parabola on our graph. You can plug it into your calculator or Desmos. So y equals negative, remember just use the subtraction sign, x squared, I'm using the a squared button for the squared, plus 4. Going up to the top to select your table. There's the table that we're going to be using. So I'll write that on the notes. -2, 0, -1, 3, 0, 4, 1, 3, and 2, 0. So I'm going to go ahead and plot those. We're going to connect them and then make sure you extend it throughout the graph. I'm plotting that reflection line, which is y equals x, 0, 0, 1, 1, 2, 2, 3, 3, and you can keep going. And then to find your inverse, remember all you're doing is you're switching those x and y coordinates. So 0, -2, 3, -1, 4, 0, 3, 1, and 0, 2. This one's going to look a little different because notice that our parabola was opening down, and also notice that it was going across that line y equals x. So notice this one does look a little different there. Okay, so we're looking at the inverse graph. So we're looking at the blue one. So if we draw vertical lines or use our pencil, notice it's crossing at two different places, which means this is not a function. Those x's repeat. So if you've noticed when we start out with a quadratic and then we find the inverse of that, notice on the last two examples, this one and the previous one, our inverse was not a function. By the way, it will be like that every time. Okay, last one that we're doing today. So y equals x cubed. We actually have not ever looked at this before. This is called, let me go back. This is called cubic because of that cube. You're having to cube whatever x value you're plugging in. So we need to go to the calculator or Desmos. We're typing in y equals x, And then I'm using a to the b power, so that way I can change that exponent to a 3. So this is what a cubic graph looks like, kind of like a snake. So go up to the top, choose your table. We're going to write down our table of values. So -2, -8, -1, -1, 0, 0, 1, 1, 2, 8. We're going to go ahead and plot those points. And then connect them, and then make sure you put arrows because we can keep going. All right, drawing your y equals x line. And then we're gonna find our inverse by doing the same thing as we've done the whole lesson, just switch your x and y coordinates. So -8, -2, -1, 0, 0 stays the same. So does your 1, 1, and then 8, 2. Okay, so this is our inverse graph, that blue one. We're looking to see if the inverse is a function. So if you use the vertical line test or pencil test, notice it's only intersecting once, which means yes, it is a function. You don't have to draw those vertical lines on there so that way your graph doesn't look messed up, because I want to be able to see your graph. I was just visually showing you the vertical line test. Okay, so if you have any questions, make sure that you communicate with us. Make sure you're working on the assignment. You can use Desmo's app, so you should be able to do as much as you can at home. And then if you happen to need to watch the lesson for tomorrow, which is notes 1, 2, which is labeled as 10-2 in Canvas, when you watch it, I used a calculator. So just know when I used a calculator, you can use Desmo's in place of that. So you're getting Desmo's today, tomorrow you're getting the calculator. So you can use either one, so whichever one you prefer. Or if you don't have a calculator at home, you have to use Desmo's. So again, if you have any questions, make sure you're communicating.